Hi, Carol.
Hey,
I wanted to say thanks for taking your time out of your busy day to speak to us today and explain to us some of the basics of audiology. Really appreciate it. I know Carol's been here at Helen Keller National Center for 9 years and has worked with the students and the mobility specialists that work here. So I really appreciate your time. Thanks.
Happy to do it.
So you were going to talk about anatomy.
Well, what I'd like to do today for everybody who's going to be watching is give everybody an overview of what I think the key points of audiology are for somebody who works in orientation and mobility. And you know, there's a lot of information that we all learn in our different professions, but what's important in terms of audiology for instructing students in O&M, that's what I'd like to cover today. And we're going to cover some basic topics of anatomy, how to read an audiogram, different types of hearing loss and how they affect all of the different aspects of traveling and communication. And then we'll also talk about how Jean and I work together in the community to try and maximize the residual hearing that students have. All right?
That sounds great. Thanks.
So to get started, there are three main parts of the ear. The outer part of the ear is a great place to hang earrings, and it's called the pinna. And in humans, the pinna does play a role in helping to localize where sounds come from. Of course, in animals like foxes, there are gigantic pinnas sticking up, and they can actually move. And that's very helpful when you're trying to avoid being preyed upon. And I guess that could be helpful in certain places in Manhattan and elsewhere. Then as you travel down the ear canal, you are entering the part of the ear where you get to the middle ear. So you have the pinna on the outside, the ear canal, and if you look at this, here is the pinna, and here is the ear canal. Now somebody unfortunately took the eardrum, and that would be right here. The eardrum is the portion of the ear where the outer ear stops and the middle ear begins. And the outer ear and middle ear really work together to transmit the sound, to carry the sound. Sound is vibrations, and when a sound occurs, it's just like when you hit a drum. If you were to hit the drum, you could hear the vibrations, okay? If you threw a pebble in the water, you would see the vibrations growing outwards. The same thing actually happens when a sound is made. As it hits the eardrum starts to vibrate. Attached to the eardrum are three very small bones, the smallest bones in the body. They're called the malleus, the incus, and the stapes. Those bones are crucial in the transmission of sound because although the middle ear is filled with air, the rest of the ear beyond that is not just filled with air. Okay? So as children are growing up, they frequently get middle ear infections, and that as that occurs, there can be a fluid buildup in the middle ear. When that sound cannot be transmitted, when those bones cannot rock and move the transmission along, you would get what's called a conductive hearing loss. So a conductive hearing loss would be anything like wax in the ear. It would be a middle ear infection. It could be the type of loss that occurs with charge syndrome, where the sound simply cannot be moved along. The middle ear acts as what's called an impedance matcher. It takes those vibrations and it gets them moving at a more intense speed so that they can be transmitted to the inner ear. Jean, do you have any questions up until this point? Do you think
No, that's really clear.
Okay.
Thanks.
Beyond the middle ear, we get to the inner ear. And the inner ear consists of the cochlea. And the cochlea is over here. And it's a snail-shaped device right over there. Now the cochlea is critical because that's the spot where the signals that come in as mechanical signals actually start to get transformed into electrical signals, right? So the sound goes into the cochlea. The cochlea is filled with fluid, and because it's filled with fluid, the middle ear is going to take those sound waves and make them stronger so that they can move all the way through the cochlea. The cochlea, if you were to unwind that snail shell, would have hair cells lining it. And those hair cells are thought to be where sounds are actually heard. In other words, different frequencies are heard at different parts of the hair cells in the cochlea. Now, if there is a hearing loss in the inner ear, that type of hearing loss is called a sensory neural hearing loss. So those sounds are now in the cochlea and they're sent by the 8th nerve up to the brain. Over here, next to the cochlea, you see that there are some spirals. These spirals are the balance mechanism of the inner ear. And that is why, very commonly, when a person has a hearing loss, they will also have their balance affected, because the innervation for the ear is for the hearing mechanism as well as for the balance mechanism.
Is that what we call the vestibular system?
Thanks. Yes, that is called the vestibular system. Now, you don't necessarily have to have a balance disorder if you do have a hearing loss, but it is quite possible to have both at the same time. That pretty much covers the anatomy of the ear, and now what I'd like to do is discuss audiograms a little bit. So I don't know if any of you have actually seen an actual audiogram. This is a replica that we use for our students who are deaf-blind because it's tactile. On this side, on the y-axis is the decibel level, and all sounds are measured in decibels. The quieter a sound, the lower the decibels. So if a person has no hearing loss, they would have all of their marks at the top of the paper, all right? Going across from left to right on the audiogram is the frequency, which is measured in hertz. We typically start measuring at 250 hertz and usually measure all the way up to 8,000 hertz. The frequencies that are really critical for understanding speech fall mostly between 500 and 2,000 hertz. That doesn't mean that some of the frequencies don't fall outside of that range, but the majority of the frequencies for understanding the English language do fall within that area. the lower frequencies and the higher frequencies, I always say, especially the higher ones, really fill in the nuances of speech and the beauty of music, and they really give a richer sound. So, if a person has no hearing loss and you went for a hearing test, the audiologist is going to use an X to represent the left ear and a circle to represent the right ear. All of those X's and O's would be above 25 decibels, all right? As the hearing loss gets greater, as there's a larger hearing loss, the marks would be lower down on the page. So for example, if a person has a profound hearing loss, a profound hearing loss is any loss at 91 decibels or below. The largest sound that we can measure is 120 decibels. That's just because the equipment for testing can only go up to 120 decibels. 120 decibels would be the level of a jet taking off. As you go from the lower frequencies to the higher frequencies, you would go from, let's say, the sound of a man's voice to a female, to a woman's voice. Men's voices typically are deeper than women's voices, and that's why quite frequently it's harder for somebody who has a hearing loss that's, let's say, due to aging to hear a female voice, because they're in a higher frequency range.
Carol, while we're on this nice audiogram thing here, where are sounds like traffic noises and other environmental sounds that are not in this range where the human voice is?
Okay, so traffic sounds are typically a lower frequency sound, and that could be anywhere from 250 lower. But the thing to keep in mind when you're doing mobility is that when a person is fit with hearing aids, usually the audiologist is gearing those hearing aids towards improving communication. Most of the time, that's the main goal of the audiologist, is to improve the communication of the individual.
So they would want to boost the decibels of the sound that the person hears in this 500 to 2,000 range, try to get that more amplified. What would they do with the other frequencies, though?
And good question. What they do with those other frequencies is really try and lower them. And you also want to try and lower any background noise. So imagine you're a person who wears hearing aids and you're outside trying to have a conversation right near Main Street, USA. You're going to have your hearing aids really trying to focus in on the person standing next to you who's speaking, and all of that background noise is going to be softened. So my role as an audiologist, if I'm working with somebody who's trying to maximize their ability to safely cross the street, would be to enhance those sounds rather than quiet them down.
So, if I'm understanding you correctly, typically an audiologist's aim is to make the human voice, person-to-person communication clearer, but in doing that, they may be filtering out or dampening other sounds in the environment?
That's really perfectly put, and that's exactly what's happening.
See, that's why sometimes it's not so good for mobility. Well, the standard hearing aid configuration might not be so good if I'm trying to have my student, say, listen to a traffic surge or identify where vehicles are in the environment. Interesting.
Yeah, and you know, the other thing is, hearing aids used to be analog, but now it's very difficult to get analog hearing aids. And there's so many benefits of having digital hearing aids, but it's always important to keep in mind what are the hearing aids going to be used for. And as O&M instructors, it's really helpful if you're aware of the different technology that is in hearing aids so that you can help the consumer address those issues with the audiologist, because it's pretty common that the consumer, the hearing aid consumer, is not aware of all of the different benefits that the hearing aids avail them of. And those benefits, while they are terrific on the one hand, they can really be the downfall on the other if they're not addressed properly. So, for example, typically when a person's in a noisy environment, the hearing aids are going to shut everything down in the background and try and focus in on the person in front of them. Well, imagine you're standing on the corner and you're trying to hear a traffic surge. If the hearing aid is shutting off at that moment, you're going to not hear the traffic.
Wow.
So
That's interesting. So I'm wondering, can you talk about the specifics of some of the things like the hearing aids? And I know there's FM systems and loops, and then of course there's the cochlear implant technology that was said.
Sure. Remember I was saying before that the outer ear does help with localization of sound. And there are basically two different types of hearing aids, the kind that fit completely in the ear, like these, which are the most common because of vanity purposes, I would say. And then there are the type of hearing aids that are worn over the ear or behind the ear. Now, you would think that if a person is wearing an over the ear or behind the ear hearing aid, that they're not going to be able to take advantage of the effect of the pinna. And that used to be true, but now with the newer technology, based on how the audiologist sets the hearing aid, even if you're wearing a behind the ear style hearing aid, you can take advantage of that pinna effect. So that's something that's really critical for O&M instructors to know.
So the pinna effect basically allows the brain to know, to process sounds that are coming in from different places, and is able to localize where the sound source is from. Is that the simple version of it?
That's perfect, yes.
Okay. So that if we have somebody who needs to localize sounds well, we would want to address with the audiologist getting the latest technology, the models that would allow the person to localize best and take advantage of that, the ability of the pinna to help them localize sounds.
Right.
Okay.
And, you know, there are, just like there's all different levels of cars, you know, you could get few bells and whistles and you could get a lot of bells and whistles. With hearing aids, it's the same way. And unfortunately, sometimes if somebody really needs to be able to localize those sounds for safety, it's important to get the higher end model. And I'm not pushing any particular type of hearing aid, but that real ear type of sound is not always available in the lower cost models.
So you talked about localization. Is there any capacity in a hearing aid like this to take away that dampening of the environmental sounds too, so that maybe a student of mine could hear that traffic surge or could monitor traffic movement as they cross the street?
Again, it's going to depend on the hearing aid. With hearing aids that have several different programs, you can have different programs for the environment that you're in. With the older hearing aids, there was off telephone, and microphone. And when you were on the microphone setting, it just picked up everything in the environment.
I think we had a technical glitch there with the camera.
Okay.
We were talking about not dampening sounds when people are out in the environment, and you were talking about the 3 standard switches and what's available now.
So with the old hearing aids, once the hearing aid was turned on, it simply picked up everything in the environment. With the new hearing aids, depending on how many programs are available, you can have a program specifically for orientation and mobility. And what I have found useful is that if you, in that program, there is usually a way where you can turn off any noise reduction. In other words, I'm letting all of that noise in. I also sometimes boost up the low frequencies a little bit, and what that does is those traffic surges are going to be that much louder. After I make the initial adjustment, what is very helpful is that I can then go out on an orientation and mobility lesson and see how that particular setting, how that program is working. The other thing to keep in mind is, you know, with some of the hearing aids, you can also have what's called zoom control. And you and I, Jean, we actually haven't tried this yet out in the community because it's new. But what that does is the person can actually control which side they are listening to. And if you're having, I was thinking, a traffic surge that you wanted to really make the person aware of initially, let them zoom to that and get used to it, and then see what it sounds like in the regular setting.
And then they'd be able to tell the difference, and if they knew that they were looking for the traffic surge on their right, then they would be able to zoom in on the right and do that.
Right.
A friend of mine uses a remote control, and she's got it in her pocket, and now when she leaves the house, she just pushes a button and she goes into her O&M mode with her hearing aid, and it's really cool because she doesn't have to fiddle around with it or anything. She just pushes that button.
Right. And, you know, there are usually remote controls available for hearing aids. They're not appropriate for everybody, but even if they're not appropriate, the controls that are available on the remote are usually just available on the hearing aids themselves. So that's something that really can be very helpful. Now, you know, more and more consumers now are getting cochlear implants, and I thought we would talk about them a little bit.
Good, because that's really an area I'm really curious about and something we don't know enough about in our field, in O&M.
And I don't think there's really been enough research for the topic to be addressed completely. But I think that what's important for instructors to know is that cochlear implants are very different than hearing aids. While a hearing aid provides amplification, the cochlear implant actually provides the stimulation of the cochlea so that it can actually work. And the sound is very different from a hearing aid. We have many consumers who use a hearing aid on one ear and a cochlear implant on the other ear, and that difference in the sound quality can be very helpful with localization, because once you learn to identify what sound is coming from the hearing aid and what sound is coming from the implant, you can use those cues to give yourself those localization clues.
Interesting, because I was looking at some of the localization studies with children who have bilateral implants, and it's interesting that the localization is not as good as we might hope. It's certainly nowhere near having two natural ears without implants. So I think the technology is always changing in this area, isn't it?
It's definitely changing, and they're trying to develop a new cochlear implant now where you would not actually lose that residual hearing that you have.
Interesting.
So,
That would be a real breakthrough,
yeah.
especially for us.
Yes.
Did you want to speak anything? Did you finish on cochlear implants? Did you say anything
No, I
else?
think.
What about the FM systems and the loop systems that I've seen students use in communications situations? Do you think any of those work for people traveling or have anything to do with us O&M instructors?
I find that it's really critical that as an audiologist I inform consumers that FM systems are wonderful for providing optimal communication, but when the FM system is turned on, the sense of localization is completely gone. With an FM system, you're not trying to gain any localization clues, you're really trying to maximize communication. So I always recommend that if a person is using an FM system, they either be sitting down or standing still. And if you as an O&M instructor want to use the FM system, I recommend using it just to give instruction prior to the lesson or at a certain point in the lesson.
Some of my students would want to have communication with members of the public. They might want to get some information.
Mm-hmm.
So you're suggesting that they might want to, if they have an FM system with them, use it just to communicate with the other person, and then when they went out into the streets and crossing streets and such, that they would turn it off.
Absolutely.
And remove any apparatus that they might be wearing? How does that work?
They don't have to remove the apparatus, but if, just as long as they go back to the usual mode that they use on the hearing aid, it's fine. With some FM systems, you have to go to a telephone setting, and if you're in the telephone setting, you will not hear sounds in the environment. So then you have to switch back to the microphone. And with other FM systems, it's through the microphone mode. And that, again, if you're in the FM setting, you're not knowing where the sound is coming from. So yes, if you need to use it to communicate, use it, hand it to the person you're speaking to, and then go back to your hearing aid setting.
Whatever setting is appropriate for traveling around. Okay, I think we're almost out of time. I want to thank you again. I can think of so many students who've benefited from your services here at Helen Keller. And I know we spent a little time on street corners together, which has been fun and exciting. Any last thoughts?
It's a pleasure working with you.
And with you. And I guess the lesson to take from this is that when an O&M specialist can work collaboratively.
That's the key point to take from this, is you've got to have communication between all of the professionals working with the consumer. It's got to happen, otherwise it's not successful.
Yeah, as we've seen on students who've come here from many places. Thanks again, Carolyn.
You're welcome.